working. And everybody, if you could mute yourselves, that would be great. Also, I'm beginning my reporting preparations and procedures. And when I go through the reports from Zoom, a couple of you have been reporting your phone numbers rather than your name and organizational affiliation. So I can't really do the accounting for you based on a phone number. So if anybody recognizes the following 3 phone numbers, please let me know. The first one is in Hemet, California. So maybe some of our Southern California folks on the line might recognize it. 951 area code 487-3513. I'm going to put these in the chat later on, so in case someone joins later. But if that sounds at all familiar, a 951 area code, let me know so I can assign your hours accordingly. Then 2 in the Bay Area, area code 408, San Jose area, 315-8143. If it's yours, it's the winning lottery number. And lastly, in the East Bay, 925-785-4251. So if any of those sound familiar, let me know. I'll put these in the chat about halfway through our call.
The 408 is me.
Really?
Yeah, I think that's my cell phone number.
Oh,
Probably the day you were at the golf course.
yeah, because I've got you under Galaxy and a few other things. So that's cool, Mike. Great. So I can make sure I get your numbers correct. Terrific. Thank you for that. So as people join, I just wanted to also announce that the electude proposal that I submitted for the region, for the 9 colleges who are interested in using electude for the fall and spring semesters, we have been approved. Yay! The only hiccup is that 2 colleges who had dropped out, that's College of Marin and Santa Rosa, are thinking of rejoining the proposal. So they have until Tuesday to let me know if they're going to rejoin or not. And then we're going to close the actual time period so we can get the contracts in place. The good news, electude is being very, very flexible and very generous with us during this process. They know that getting a contract in place and being paid will take months, and we would miss the fall semester, most probably. So they have agreed very generously to go ahead and give us the subscriptions without being paid, which is unheard of, but very much appreciated. And those of you who have been using the trial version of electude, that will not expire July 31st. That will remain open. So there will be no disruption. So the subscriptions going forward are going to be 6 months in term, not 12. I negotiated that flexibility so that if a student drops out after a couple of weeks, we will not lose that subscription for 12 months, but just for the remainder of that subscription period of 6 months for the semester. I will be putting all this together in an email, and maybe we'll do a Zoom call at some point in the future with electude so everybody understands how this is going to work. I will need a representative from each college, and I don't know if it's going to be a dean or SWP person or faculty. I'll have to research that, and electude and I will be coordinating the management of the process so that we don't drop any subscribers or lose anybody in this process. But this is very good news, and I'm excited for all of you. There will be a faculty online training as part of this for electude. So hopefully that will not be too onerous or burdensome in terms of your schedules, because I know some of you are trying to sneak in a little vacation time before school starts again. Anyway, if you have questions, I'm here, you can contact me. But this is very exciting. And in terms of the Mobilize Summit, as most of you know, we had to reschedule it from July to October. You may have gotten the email, I hope you have, that we have again rescheduled it from October to February 3rd through the 5th, 2021. I am trying to get funding for some of your travel if you want to go down to Temecula for it, as you did last year. But funding is going to be tight, as you all know, but I'm going to do my best to see if I can get some funding for you. But that's going to be in February now, February 3rd through the 5th. And Lastly, regarding what we're doing on the phone today, we are approaching the last couple of training sessions. And this has actually been so much fun. And I've enjoyed working with all of you over the summer. Seeing you every week has really been the highlight of my week. And Kurt has been absolutely fantastic. So I do want to incorporate, and Kurt and I are talking about how we're going to structure this into the last one or two training sessions, a discussion about what are the next steps with ADAS, how each of the colleges is going to basically use the curriculum and go forward teaching, and how we can support that activity. And also the new basics and fundamentals for our programs going forward. So we're going to have that discussion time somehow organized in the next one or two sessions, and Kurt and I will let you know. But before you all fall asleep on me, I'll turn it over to Kurt. So welcome once again to the ADAS training session. Kurt, thank you.
All right. Happy Friday, everybody. Not a moment too soon, too. Oh, we still got everybody? Because I lost all my pictures here. Let's get back. There we go. So today's going to be busy. Just no way around it. There's some meat and potatoes on this one today. And Pam will have to let those people in because every time I touch a button someplace else, it blows me up.
Yeah, I've got it.
All right. So today's seminar 7. Oh my God. They just keep going forever. Same stuff as always, not a deep dive. We're not trying to certify anybody. This is, for educational purposes, give us all a better foundation on what these systems are, what's going on with them. Remember, you can pull these down. You can pull the video down. You can pull the presentations down and use them in your classes. This is wide open. Had one gentleman from down south who's involved with ASCCA ask, can he show them and share them with ASCCA? I said, yeah, they're public. So don't be afraid to share it. If there's faculty that haven't attended, make sure they're aware of it. I mean, I would like to think there's something that somebody gets out of every one of them. It might be just one thing. It might be nothing. It might be just a good session to laugh at, but it's better than you had otherwise. So let's keep using them where we can. Agenda today, traffic sign recognition and autonomous vehicles. Traffic sign recognition is really the last, quote, ADAS system that we're going to talk about. Autonomous vehicles is really going to be that evolution from autonomous. And then the next 2 sessions will be about vehicle communications, which is a very big thing. It's already existing, it's growing rapidly, and it will be a large part of what makes autonomous vehicles much more integrated than we think. And don't think just cars. This is all the way through tractor trailers and everything in between. So that's a big one. And then programming as well. And the programming one has been a discussion forever. All of our advisories are always talking about programming. So I wanted to put something together with programming because it also has a lot to do with semi-autonomous, autonomous, and things like that, as well as just fixing cars nowadays. So those last 2, there's a reason why they're standalone topics, most definitely. Don't forget, you can get everything up on that ATL site, and they've been really good about posting it. I usually send the presentation to the people right after we do it. Pam's usually sending the video the same day or a day or 2 later. So they're typically up by Monday or Tuesday of the following week. So there's not much delay on being able to get to them. Bosch stuff is also up there. Make sure you're using the area that's the new online or the new webinar based stuff. The older stuff is what's up on the screen there where it says the ADAS Advanced Driver. These are the skeletal ones. So this is not the revised or polished up stuff that I've been presenting with you guys. Additional opportunities, and this is something to keep in mind as we, look like we may be challenged with students and things like that. Industry is really going nuts to get training. We need to think of it beyond the car dealership. We need to think of it beyond the independent shop. Start thinking about the collision industry, thinking about glass, thinking about fleet. And when I think fleet, I think heavy duty truck. Fleet is everything from a Toyota Prius to a heavy duty truck for a county. You have some of these fleets that have 600 technicians. scattered across different areas, according to some people I talked to the other day. So fleets are a huge thing, and the heavy duty side especially doesn't have a lot of training when it gets to ADAS and stuff like that, or even the EV side. The companies that are building an electric bus don't really have a lot of training to support their to support their technicians. So they're looking for it. Well, you have hybrid and electric classes almost at all of our colleges. You could take those fundamental things and build industry-based classes. That's revenue source. Or look for grants, scholarships, things like that. That's providing opportunities to your programs that could be, you know, beyond the general fund type of stuff. Also look in the different industry events like Mobilize, Clean Cities. There's huge clean cities agencies throughout the US. These are much more of the fleets, the municipal fleets and things like that. And it's all focused around, you know, clean vehicles. It's the electrics, it's the hydrogens, it's the alternative fuels. But they have technicians tied to that and funding tied to that. And they need EV and ADAS desperately. And they're very rapid on the movement towards semi-autonomous and autonomous, especially in the heavy duty area. You've got another group, which is the Green Transportation Summit, which is similar to Mobilize and Clean Cities. And then ASCCA, they're constantly in need of training. And I know Pam sits on a couple of those groups, and they're always asking, and some of this may evolve into the technician stuff. And, you know, one of the things I've kicked around in my head a little bit is maybe I can build out some rough course outlines that could be, you know, a foundation for industry-based classes, to where it's really just focused on basics on batteries, basics on motors, basics on converters, inverters, safety, those kinds of things. The kind of a watered down version of what we do in our regular classes for our automotive, focused for industry technicians, to give them that introduction level foundation. On the slide, there's actually going to be, in the slide notes for this page, there are web links for these different groups. But there's a big push here. And because a lot of this is regulatory driven, you know, California in 5 years, if you're a medium duty truck, you're electric. By, I think it's 2030 or 2031, if you're a heavy duty truck, you're electric. So, you know, they haul 3 trailers in Nevada, and in California, they drop 1. Well, now they're going to drop them all and switch to an EV. So this is big. There's a lot of people they're going to be dealing with this, not just the handful that there already are. And you find out from a lot of these fleets, they got 1 guy or 2 guys that are the electric people in their entire fleet. And they send a lot back to the dealers because they don't know anything about it, even for basic service work. So here's a huge opportunity for your programs. And I know Pam's working with the heavy duty areas to develop that stuff. So let's get to something we're doing for us. So traffic sign recognition, few different names out there. You'll see traffic sign recognition, or TSR. You'll see traffic light recognition, TLR. It really comes down to whatever they want to call it. Its whole idea is it's using those cameras that we already know well to look at the signs, to read the signs, and bring that information back into the vehicle. So let's see how this thing works. This one's a little slow to get going usually.
Traffic sign recognition. When your vehicle passes a speed limit sign, a camera can detect the limit and display it on your dash and head-up display, part of the Honda Sensing suite.
So real quick, simple, to the point. But what does it give us? Well, it gives us that posted road sign. We already figured out that our drivers aren't really paying attention and they're going to drive whatever speed they're going to drive. But at least now the system's telling them, hey, the speed limit's 55 or it's 65 based on the signage. Theoretically, that's going to improve our passenger safety. We're going to impact our accidents and all that kind of fun stuff. But what's going to start to happen is these systems can now start to integrate in. So let's say you're on the active cruise control and you're in a 70-mile-an-hour zone and you've got it set at 80. That system, if depending on how they have the algorithm set up, could bring the car back down to a 70, or as you transition from a 70 to a 65, it could bring that car back down to those speeds, regardless of your settings. So this becomes part of that integration as we move more and more towards the autonomous. This becomes a featured piece. So it's a nice, but down the road, it's probably going to have a larger impact. So it's seeing the posted signs. It can use it for navigation systems. It can use it in the instrument cluster, in the heads-up display, however it wants to convey that information to you. Maybe it is giving you some sort of a chime or an indication or a vibration if you've exceeded that speed limit. We've all seen on a lot of navigation systems, or if you've got Waze and things like that, the speed you're going versus the posted speed limit type of thing. Think of it as that same mindset. So there's a lot of different ways that this could be applied to the vehicle. How are we doing it? Cameras. We're using that same camera that we're using for lane departure, that we might be looking at for some of the pedestrian protection and other things. We can start to use these cameras for other systems. Remember, the camera, I can use it anywhere I want. I just take that information, I share it over a bus, or I send it to a particular module who then shares it to whatever subsystems, whether it's internal or external. Obviously, it's going to have a module or multiple modules involved. If it's just tied into having some interaction with the cruise control, hey, you're going to have the engine management in play. So different things are going to be involved with that. Control switch, this may or may not be a system you can turn on and off. What we find is a lot of the ADAS stuff, some things you can control, a lot of the time blind spot monitoring and those kind of things you can turn on and off, and other things that they prioritize much more of a safety issue, they make it so you can't turn them off. You know, think back to ABS. ABS, you can't turn it off. When we got stability control, you could turn off the stability control, but you can't turn off ABS. So we've got that same evolution going on with these types of things. Indicators, okay, instrument cluster, maybe it goes onto the nav screen, maybe it goes into your heads-up display. Wherever they choose to put it, those are chances that you could utilize them. Diagnosis. Well, by now you've heard me say a million times, the number one thing to look for is physical damage. Physical damage, whether in this case it's the windshield or tints or weather conditions, snow, ice, fog, smoke, all that kind of stuff. But what comes into play with these is the clarity of the road signs. So what you can see is when you look at, you know, our half-covered stop sign, the system may be able to, if it has enough logic built into it, it may recognize that, hey, that's a red sign and it looks like a stop sign. Or it may just be able to calculate enough and say, okay, that is a 25-mile-an-hour sign. So there's some variations that can come into play as to, depending on how evolved the system is, as to how sensitive it could be to obstructed signage. The other thing you're starting to see, and I've seen them in my town, is we're seeing the stoplights that now have these bright yellow borders around them. And where I've seen it the most are in areas where they tend to have a high sunlight background. But what I'm also suspecting, and just doing a little bit of reading on, these are some of those steps that you're starting to see come into play for infrastructure to support semi-autonomous and autonomous vehicles. California, last year or two ago, got rid of the bumps that we used to have between the lanes. And they've gone to the wide tape or the wide paint because it's more reflective. Well, in talking with some of the Bosch people 2 years ago, there's already worldwide a lot of standards being put into place to support autonomous vehicles in the future. So if I can make those lines more noticeable, that helps autonomous vehicles. If I can make signage, whether it's on the day or the night, more noticeable, it helps those vehicles. So we're probably seeing some of these things start to take place and not even knowing what it's meant for. Yeah, it helps you whether you're a camera or not, but if you're a camera, it's really going to help you pick out that sign in the middle of nowhere, because now instead of just seeing a red light that you might think is on a building or something in the distance, well, now we've circled that or squared off that red light with a box, and now you know, hey, a red light in a box is a stoplight. Back to that logic for the systems. So, and then we've talked in the past, it's a good time, you know, after 1 or 2 sessions, the students should start to pick up on the sequence of diagnostics. So with that, you know, hey, throw a blank flow chart up there and start saying, okay, what are we looking at first? What's second? What third? Okay, well, let's look at the electrical side. What are we looking at first, second, third? Those kinds of things. So there's ways that we can convey this information through the repetition of it, and they could come out the other end and say, wow, I've got a pretty good idea what to check on these things because I've heard it 52 times. Okay. Now, since we've been talking about diagnostics, I wanted to use this last ADAS focused topic to let's expand our diagnostics a little bit. So this is a wiring diagram. It's out of all data. Happens to be a BMW just because it was a prettier diagram than the others that I found. And this is a camera-based system. So in this case, here's my windshield camera. And we've talked about what do we need to check on a camera? Well, we need to check power. It's got one power coming in. It has one ground. It actually has a heating element so that the camera doesn't fog up, like in the cold mornings and things like that. And you will see that commonly on a lot of cameras. Same thing on the night vision cameras in some cases may have a heating element, as well as the, I know the earlier versions of the active cruise controls, the ones that kind of look like a little fish eyeball, those had a heating element on them as well to keep them from fogging. So we've got a heating element, and then we've got a bus. And in this case, it's Ethernet. Ethernet on later model cameras because of more data flow. As we get into these more hungry systems, we can have a higher refresh rate, we can have more data flow, we can have more precision. And you do have on some of these modern cameras, they're not just, don't think of it as a one lens. Some of these more modern cameras have multiple lenses to where they're looking at a short distance focus, a medium distance focus, and a long distance focus. So again, even more data rate that we need to transmit. And it is its own module. So it is taking that information, it is converting it, and then it is sending it over the Ethernet. In this case, it was going to the body domain controller, who's kind of the big boss, who's going to have other information going in and out. So in this case, that same camera would be used for our lane departure. Well, lane departure is going to shake the steering wheel for me. So it's coming out over a LIN bus, single wire bus, going to our steering column control switch center, going to the steering wheel module, and going to the vibration motor in the steering wheel to give us that haptic feedback. When you look at these circuits, and this is the nice thing about a lot of the new vehicle technologies, they become very simplified. I have a power to a module, a ground to a module, and a communication. And if I have more than that, I might have a couple of powers to the module, depending on how many things it's controlling. Like a door window switch might have 2 or 3 separate powers coming into it. One for the door module itself, low voltage, or a low current circuit. One that would be a higher current circuit for, say, the window motor. And maybe a third one that is going to be for the door airbag or other door features. So when we start talking to what our students need to be able to do, they need to be able to use a DVOM, take basic voltage tests. They need to be able to use an oscilloscope, because the only way I can confirm that communication is I've got to see it. Yeah, I can look at it with a voltmeter, but I'm going to see a hertz, and that it doesn't exactly tell me if it's talking or not. But if I see that oscilloscope and I can see that communication, I know what it's saying. I know it's talking. I don't care what it's saying. It has the ability to communicate, and that's what we're confirming. Now, I could still have it saying the wrong thing. I could still have a software issue. I could still have a hardware issue, but I know that the bus has capacity for communications. That eliminates things for me. Bus diagnosis, that's a whole nother animal. You know, I know a lot of you came into Mike's class and you went through that, and bus diagnostics can be time consuming. You know, if you've got a flat line somewhere, you're taking things apart to unplug modules, the dreaded unplug method of finding out who's killing the bus type of scenario, or finding the break points and disconnecting those at the splice points and such. So the bus diagnostics come into place. But other things to keep in mind, this camera, yeah, we're using it for lane departure, we're using it for other forward-looking things, we're looking at for our sign recognition. But if I've got a customer complaint, let's say in sign recognition, but I don't have a problem with lane departure, is the camera my problem? Probably not, because it's the same camera. So now I need to be looking more, hey, I probably have a software issue, not so much a hardware issue. So being able to back up and say, hey, this is also used in these other places and they look good, that's not a problem. And that becomes a bigger thing because we're using these radar for multiple things. We're using these cameras for multiple things. Unless I have multiple systems down where now I can say, yeah, that camera is the most likely thing because it is the most common cause or the most common point between them. So there's some ways we can use this. So this is a camera-based one. Let's look at a radar-based one. So this was off of, again, ALLDATA. So when you're looking, if you're trying to find diagrams, what I found is I go in the diagrams and I look for the accessories and options area. And then I look for, it doesn't usually say ADAS. It'll usually say driver safety systems or collision prevention systems. And you can pull down a little bit, but almost every car I've tried to look for something on, I have found something on. Some diagrams are much better than others. So this is a Subaru, and it is not politically correct. And that is, you know, especially with today's stuff going on in classes and in schools and everywhere else, you know, we do have to have that discussion, you know, the whole master and slave terminology that our industry uses, and have used it for a long time. The definition at the simplest level is really the master module is doing more processing than the slave module. That's it. So that slave module over on the right-hand side, he's doing his job. He's doing everything he's supposed to do. He's talking to where he's supposed to talk to. And anything beyond that, he's sending back to the other guy to forward it. That's it. Our industry's got this terminology in a lot of things for a lot of reasons. And it's going to take that brief explanation to explain why it's being called that way. Will it change? I don't know. I think it will eventually as they start to go in there and clean them up. But it's important that people know why they're being taught that, why it's being conveyed that way. They don't do any less. They're just not doing some of the outside communications. So with this one, we've got a power coming into the left-hand radar. We've got a second power coming into the left-hand radar. We've got our ground. We've got an output to the mirror assembly, which in this case is for that light bulb for the blind spot monitoring. We've got a communication to the right-hand radar sensor to be able to take information from it and share it back to other systems. The right-hand radar sensor's got a power, it's got a ground, and it's got direct control of that outside mirror light as well. So with the left-hand sensor, that's the one that's connected up to the network and communicating with the rest of the vehicle. So again, we're back to very basic, fundamental electrical testing. The most complicated thing is going to be using the oscilloscope to confirm your communications on the bus. That's it. And this ends up being timely. I got a phone call yesterday. A gentleman, his girlfriend had bought a new Subaru, less than 1,000 miles, got in a rear end collision, went to the body shop, got repaired, didn't sound like it had structural, and she drove, the body shop sent the vehicle to the dealership, had it calibrated, brought it back, delivered the vehicle. She drives it. Once she gets about 3, 4, 5 miles, the lights come on saying there's a system fault. Takes it back to the body shop says take it to the dealer looks at it and says we can't fix it. This is a brand new car with 1,000 miles that's had a moderate or even mild rear end collision. So we start talking to him. Well, yeah, it doesn't, if they just took it for a mile, which the repair order looked like, it just drove it for a mile. And he said, historically it's 3, 4, or 5 miles before it'll come on. So that 1 mile wasn't an adequate road test. So my conversation with them is, okay, did the body shop calibrate in the first place? Well, yeah, they'd send it to the dealer. Okay. Did the dealer pass it? Did it pass the calibrations? He says, yeah, they charged him $200 and it went through the calibrations. So do we have a calibration problem? Probably not. Do we have an intermittent problem? Sounds like it. So that 3, 4, 5 miles. So one of the things I said to him, I said, well, go out and drive down the street and, drive next to the car with another car and see if it picks it up. Because if it picks it up at the, within that first mile, the system's working. So why is it not working after 4 or 5? My thinking is that sensor's heating up. That radar sensor is heating up over time from whatever reason. Maybe it's a part failure before it, or maybe it's from the accident. And that because it now has had enough reflective input that it's heated up and it's saying, hey, I'm done. And then it goes into fault. Because she'll turn off the car and sits overnight. The lights are off. The system works until she hits 3, 4, 5 miles again. So some of these things are going to take a little thinking. That car was in a collision. Your first concern is the structure correct? Is it off angle? Did it calibrate? Well, those seem to all be checked off. Does it fail all the time? No, it fails after a parameter. So back to all of our other diagnostics, knowing what the finite details are of when did it happen is now going to start to come into that diagnostic. So in this case, if that sensor fails after a period of time, the dealer could make the argument, well, it's crash related. It shook something up inside. The body shop could say, well, it works, for the first 2, 3 miles. So I said, well, you need to get the insurance company involved too, because this could still be a result of. But that's not any different than any other kind of diagnostics we've done on any other system. And that's the point I wanted to make with that example is these are the same kind of parameters, examples, scenarios, situations that we've dealt with all vehicle systems forever. It's just getting through all those pieces, getting to that finite conditions to where something fails and then testing it then. Hopefully that makes some sense. Now, with the calibration side of things, we've talked about it many times over. These are cameras, so we're targeting. Maybe there's some self-calibration involved, but I wanted to bring in a little bit more information this time. So the last piece there, it says impact. And this happened to be some information that came from a Honda. And they said 0.4 of a degree out of alignment meant 6 inches of out of alignment for the cameras on one part of the lane, 15 inches off of the alignment on the other part of the lane for a lane departure, lane recognition system. So basically this whole camera system was now canted one way because it was only 0.4 of a degree off. So it's a very small amount. And the picture in the lower right there, when you look at it, you go, okay, 1 degree of difference. Look how much distance changes from that vehicle. So 1 degree of difference, one of them is here, one of them is out here. And in this case, they're talking about a stopping distance. So if I had this 1 degree too low, too pointed down, and the car is out here, I'm not going to see that car. I'm going to react too late, and the vehicle's probably going to crash. If it's calibrated where it should be, it's a substantially farther lead time on recognizing that vehicle and preventing that crash. So we've talked about this from day one, that expanding cone. So what seems like a small amount, 0.4 of a degree, that's a huge and ever-growing amount the farther away it gets. I mean, I've heard the thing of like 10 to 12 feet at 100 plus yards. You're now looking in the other lane. You're not even looking at the car in front of you now. You're looking at the car in the lane next to you or the car in the oncoming traffic. So these little amounts matter. That's why, the thrust is so critical. That's why the collision repair is so critical. Having it securely mounted is critical. So hopefully this gives a little bit more insight to some of the effects of these things. So like I said, this one's not too heavy. So we'll hit some questions. Let me skim up here. Oh, people were talkative today. Let's see here.
Hey, Kurt.
Yes, sir.
Hey, before you showed a picture of a vehicle and then you showed it the rear view mirror, there were several more sensors than I've even seen on cars.
Yeah, there are about 4 cameras on that thing. So what you have with some of those, you'll have some of them will have the lane departure cameras. Some will have a short distance camera separate. Some of the earlier ones, you had a short distance camera separate. Some of them have a medium distance camera separate. Some of those could have been the light sensors for your ambient light going vertical and horizontal. You've got rain sensors on there, but yeah, there's a few of those where, you know, they just started putting more cameras on there. And then as the electronics improve, it, you know, they incorporate those things back into one camera and stuff. But yeah, there's a period there where you see 3 or 4 cameras on some of the cars.
By the
As they
way,
do
I saw
share.
a Hyundai Sonata today when I was at Costco, and they had it out front, and it was loaded with ADAS systems.
Mhm.
And I don't know how much a Hyundai Sonata had a 1.6 turbo, right? But this thing was going for 35 grand,
Yeah,
which I think is high.
it's high, but you know, put that same technology in anything else, you know,
Well,
that's
look,
a mid-sized car.
yeah, I mean, I got a hybrid with all those sensing systems, which hybrid is expensive too, but I got that for 40, I think it was 46 new or something.
Yeah.
So I
Yeah,
don't
they're
know.
getting expensive. One of my brother-in-laws just bought a brand new Ford F-150, 54, 55,000.
Yeah,
Ouch.
a lot, huh?
Ouch. All right, so Ed had one that chimed in here. A couple weeks ago, Elon Musk was talking about ADAS and driverless cars ready very soon. An engineering instructor was challenging his claim. There's a lot of technology already in place. I mean, the bottom line is ADAS is the foundation for autonomous, flat out. Autonomous is the brain, it's the logic. And a lot of that logic is pretty good. I wouldn't say it's there yet because we're constantly finding new things that, new scenarios, new situations that the logic hasn't figured out yet. That it either hasn't been taught or it hasn't self-learned yet. But then again, we got a lot of drivers that do stupid stuff in the same situation. So it's a little bit of a trade-off there. It's a lot closer than people think. It is truly a lot closer than people think. And then when we talk about autonomous here in a minute, we'll start to see some of that a lot more obviously. Mark Childers, can these systems work with nav? Yeah. And that was a lot of the intention behind them, is that they would work with the nav to superimpose that, that information onto the page. What you have with some of the newer hybrid and EV cars, if you've plugged in a destination, you now have some active control on some of these vehicles to where they will charge and discharge on like a hybrid vehicle based on the driving map. So if they know you're getting ready to climb a hill, it's going to recover the battery a little bit. It's going to use a bunch of that battery assisting over the hill. And then when you coast down, when you're coming down the other side, that way the battery's drawn down and it's going to now use it for regen to recapture. As it if it knows you're going to go into a city, it'll use a bunch of the, it'll stay off the battery on the highway, let's say, so that it can do more electric driving in town. So there's some activity coming into play more and more with navigation systems and vehicle automations and stuff like that, or functionalities. So yeah, it's meant to work with the nav. Rick Marshall, let's see here. John Taylor, what about rumble strip wake up zones? Will they still remain? You know, until there's nobody driving, it's still going to be there. And let's be honest, if I drive even a stability controlled car or just an airbag equipped car, we've got those sensors in the car. If I drive over the rumble strips, those sensors are vibrating. Why couldn't I take that information in as another source of information and say, okay, I might not see the lines, but I feel the rumble strips. I need to, you know, oh, by the way, move the car over some. So I look at that as being another sense that the vehicle has. We just may not be, it may not be built into the algorithms yet, but why wouldn't it be? The sensors are already there. They're already doing other things. If they're getting a vibration, why not tell somebody? So that just, to me, makes logical sense. Michael Clyde, I think so. My nav system displays speed limits. No ADAS really. One is a 2010 Shelby with nav. The other is a 2018 F-150, but it does have adaptive cruise. And you will see in a lot of the navigation systems, they'll post a posted speed limit, and it has nothing to do with cameras. It's based on the mapping. So the map providers have already built those things in. Where it becomes a problem is like construction zones. posted speed limit 65, now it's a construction zone and it's 50. Well, your nav is still telling you it's okay to be 55. If you had a camera-based system, it would see the sign for 50. And if it is one that could adjust the cruise, maybe now the car comes down to a 50-mile-an-hour cruise. The location of those signs becomes critical because the systems are kind of taught to look in certain places. And that was one of the standardizations that they've been trying to do is road sign location. If you've ever driven in Europe, there's a lot of places where you don't see road signs where we traditionally see them. They paint it on the road. So signs and markings and things like that, they're just painted right on the road surface itself and not as much signage. Well, in the dark at night, in the rain, it's really hard to see those things. Well, now in the last 5-10 years, Europe's getting more and more road signage so that these systems can start to pick up on those better. So it's just a lot of little infrastructure things that are happening to improve this. David, will sensor fusion work with GPS data, verifying things like speed limits? It could, and that's the thing. It's just another line of software. We have that information coming in. It's now just a matter of somebody creating the code to say, hey, take this information into consideration when you're doing this. And GPS is not the future of cars. You know, the traditional GPS system. The future is satellite based. And you already have some of the new technology manufacturers that are looking to use satellites to replace the traditional GPS. They're going to use satellite location for the vehicle for more geospatial location because it's more accurate than the GPS, and they can move more data that way. Because with GPS, you know, you get the clock and the position. With a satellite-based system, hey, you're getting your radio, you're getting navigation, you're getting whatever they want to feed to you through that system. Don't be surprised if, you know, Tesla's putting that stuff up in the sky for more than just for you to make phone calls or have broadband in the mountains. Something to think about. John Taylor, typical amps for camera heaters. You know, I couldn't tell you, I haven't measured one. It's not much because the wires going into those things is small. So, you know, if it's an amp, I'd be surprised. It doesn't have to heat up much. I mean, even the big fisheye we had when it first came out on Mercedes or on BMW, it was about a 3-inch, if that, fisheye. So it wouldn't take much to heat that lens, and you wouldn't want to heat it a lot so that you don't start creating fogs and thermal issues. Let's see here. Paul, will there be system software updates or campaigns for the systems? It depends on the component, but yeah, I mean, with any of these things nowadays, most of the computer systems now are built with EEPROMs, electronically erasable, programmable read-only memory, to where they can go in, erase the whole thing and rewrite everything, or go in and replace certain sections. Though some of the hardware things, like a radar sensor, it may not be reprogrammable. It may be hardware limited, and you know, if it needs an update, it gets a new piece. But oftentimes they'll have something like that be kind of, we'll call stupid, to where it doesn't need that much logic, but the module that it's communicating with or that's controlling it, it would be updated. So if I use that BCM diagram that I showed earlier, the camera might not get an update, but the BCM would. So it's kind of dependent on what it is. But a lot of the time, the cameras and the sensors themselves, probably not. But the modules that are more in charge or doing more work on the broader scope, yeah, they would definitely be. And yeah, campaigns, recalls, component improvement. And the other thing to think about, because we have the ability to do software updates and stuff, if we build a car that already has the hardware on it, so it's almost it's almost impossible to buy a car today that doesn't have a navigation screen, even if it doesn't have navigation. You want to buy navigation? Hey, an extra $500, you go to the dealer and you get it programmed in. And basically what are they getting? You're getting a code key and the map. And they go in, they program it, they tell that stuff to turn on, and they load the map, and you now have navigation. You always had the hardware capable. Now they just enact it with software. Tesla did it with some of their batteries. They had cars that had the 90 battery, but they were detuned through programming to a 75. And you hear about it in some of the big hurricanes and stuff, to where Tesla will push out an update and it will allow the batteries to have more capacity than they originally had. Well, that means the hardware was there and all they did was reactivate it. So we may see more and more things that become software enabled that their car is already built with. And from a manufacturing standpoint, there's goods and bads to that. Yeah, it's great for the customer to be able to add it on. It's a little more expensive up front for the manufacturer to produce. But if I only have to produce one module now versus 4 different versions, it saves me some money. So there's a lot that comes in. Software and stuff, and it's a whole new world when we talk about programming. That one really comes in. James had a good description. Server and servee. That would be a good one for the master-slave discussion. Mark, how about controller, non-controller, master and puppet? Oh, that's terrible. Ruben's got something there. I never open them because I don't know what it's going to do to the thing. I don't want to blow everybody up, including me.
I was trying to share a string of lights that I saw while traveling, and it's and I send out the whole file. If you are interested, look at the last picture on there.
Okay.
But what I saw was I was going down through some traffic lights. There was a string, Kurt, and there was at least 10 lights on it. So the first thing that I thought about it was, what would an autonomous vehicle do in this situation? Because I didn't know which one was pointing at me. I was confused. I just went when I thought it was about time to go, you know.
One of those lights was green and I went. Yeah, and that's
right.
That's exactly the kind of learning curve that is going on with these vehicles. So when you look around, you know, here in the Bay Area, we see it especially, and San Francisco even more so than probably anybody else. Cruise, I had a student that was a driver for Cruise. So basically he sat behind the steering wheel and the car drove around San Francisco all day long. Every trip is recorded. Every night it comes home, it downloads, and it runs through the database. So that one road test will be driven through the virtual 1 million times. And the different companies actually share those road tests. Quite a few of them have made it public to speed up the learning process, because every time the vehicle drives, it's taking information that it can now learn from. And every time they make a change, so if they drive from A to B today, and they go in and they make one small change to anything in that system, they go drive that exact same drive tomorrow, because it's almost like it has to learn again with its new capabilities or its new knowledge or its new experiences. So those trips, those things are huge. And every time they drive, they find that thing, like 10 lights on an intersection, or the guy that, you know, turned from, you know, the parking curb and went, you know, sideways through all the lanes to go the opposite direction. All those weird things that we experience driving normally, and that we're able to process and do something with, the AI has to learn and has to learn how to process it. And we'll talk more about that here in a minute when we get into neural networks and things like that. Stephen Brady, do you know, is there any push to make some of the infrastructure more interactive? For example, I cannot understand why traffic lights are not more interactive with infrared and other sensors. How many driving hours and millions of gallons of gas are wasted late at night and every year in a single car is idling at a red light on an otherwise empty street all over the world? I saw a light like this in Germany about 5 years ago. It became active as cars or people were around. Otherwise, the main road stayed on green or jump. Welcome to next week's conversation. Connected vehicles. Connected cities. That is the next steps. And a lot of that, there are aspects of it now. There are actually, I think it's a half a dozen or a dozen cities already around the US that are what they consider connected cities that have some of this infrastructure. It is well in development on the cars. What is the biggest holdback is Wi-Fi is not sufficient enough to move the data. 4G/LTE is not fast enough to move the data. A lot of what is going to change the world for connected everything is 5G. And we'll talk about that next week when we talk about communications. 5G will bring in a lot more of this, and car to car to everything, you to everything at that point as well. Check that out. Recognize this. German engineers make practical solutions. Yeah, but you know, whoever came up with it, they're the ones that did it. Loose bad connection problem with the 5-mile failure. Yeah, it could very well be. But I would think that would be something that, you know, once it was loose, it would stay loose. You know, why is it that long before it finally gets loose? And then how does it reconnect when it sits? But yeah, it's one of those, you go back and you check those kinds of things. Let's see here. Paul, misaligned camera, would this cause the system to disable? Camera disabling is a little different than radar disabling. With radar disabling, a lot of the time it's getting a return too fast. So it's sensing an object being too close, so it says, hey, I got a fault. The cameras, they can go into a fault, but oftentimes if it sees something, it doesn't really know that it's right or it's wrong. But if it sees a bunch of white, you know, like it's looking into the sun all the time, or, you know, or if it just sees black, like it's looking down at the ground or whatever, it just depends on the level of logic in the system. The ones I've seen, some of the early ones, they were really sensitive, and the camera would turn off quick. If it saw like a static thing on it for too long, it would just, and it would throw the faults. The newer ones I haven't played with to say how advanced their logic is to where they recognize I'm not seeing live objects, I'm not seeing moving objects, I'm seeing static too much before they send a fault. That'll be really interesting to see as we get more and more and more. Try to send a visual fix, no problem. Ed, the new 007 car will be equipped with these systems adapted for his spy weapon systems. Q will soon be replaced. Rumble strips can be frequency calibrated. Yeah, there's some roads that sing to you. Can't remember where that was. It was like in the Nevada desert or something like that. They went out there and cut the lines in such a way, and the car would make music as you drove on them. GPS is global positioning, yes. And that is a fixed series for the military-based satellites. When we talk about satellite nav, it is a satellite that is not using the global positioning stuff. I talked to one guy who was, you know, arm's length away from a manufacturer, and they were talking about using satellites, you know, for data into the cars and stuff like that. And they were talking about the same satellites that would bring you, you know, your Sirius XM radio or your DirecTV, things like that. So not global positioning network, more of a true satellite communication-based network, which will be interesting to see, you know, with Tesla's, whatever it's called, Starlight or whatever they've got up there. You know, he set it up to be an internet in remote places. Why couldn't your car hear from it too? More humor from Ed. Did they ever correct the course of Elon's Tesla he launched in space, or is it still heading into the sun? Yeah, I don't know. I thought it was halfway to Mars, but who knows? Ed Lancaster. I think it was Lancaster that had the singing roads. Yeah, I think you're right. All right, so I think we're good there. Okay, guys, so strap in because now we start getting a little bit more heavy lifting going on. Autonomous vehicles. Love them, hate them, goods, bads. This is a great point of discussion for your students. For the gearheads, they're going to hate them. I want to drive my car. If you commute for a living, you're going to love them because I can get an extra hour of sleep. If you're handicapped, if you have vision issues, if you're elderly, all of a sudden that autonomous vehicle becomes a critical connection. So autonomous vehicles are very polarizing in discussions, but at the application level, there's a lot of goods. There are possible some bads too, but you know, human drivers run people over too. So we want to rationalize things a little bit. So the who benefits is a big deal with this. So there's a handful of videos I've got in this one. So there's going to be some pieces where we're sitting and watching for a couple of minutes on a couple of them. But let's start out like I like to do, you know, a video that gives you just a quick overview of what it is.
You've probably read something about autonomous vehicles in the news, but what are they and how do they work? Well, they use sensors, lasers and cameras to navigate the roads, and there are actually 5 different levels of automation. Today, your car is at level 1 with features like cruise control and parking sensors. But by level 5, the car can drive itself completely. All you do is tell it where to go. But what does that actually mean? Well, with computers at the wheel, you'll get from A to B faster with less congestion and less pollution. Once you arrive, your car will even park itself. But their biggest benefit is safety. Every year, more than 1 million people are killed in car accidents worldwide, and 90% of them are caused by human error. Sometimes we get tired, we lose concentration, and every now and then just get it wrong. Could driverless cars be safer? They'll have to be able to make quick decisions in all kinds of situations and share the roads with conventional vehicles, pedestrians and cyclists. There's still a lot of work to be done, but driverless cars could dramatically cut the number of accidents on the roads and save millions of lives. That doesn't make letting go of the wheel any easier though. There are still lots of unanswered questions. Who's to blame if there's an accident? Can autonomous vehicles be hacked? And what if you're someone who just likes driving? To find out more about what an autonomous future might mean for you, visit FIA.com.
So there's a little bit of an overview. So now we got to get a little bit deeper in this. There's some definitions that we need to be aware of when we talk about autonomous. There's actually 2 different definitions, one by SAE and one by National Transportation. And they're very similar now. They've kind of evolved. One originally didn't have a level 0, one did have a level 0. But let's simplify it. So a level 0 is basically no animation. It's you driving. Traditional old school cruise control does not count. All right, so this is just a plain old car. Level 1 basically means it has at least one system. Most commonly, it was a lane departure, a lane keep, or an active cruise control. Basically, it was a system that did some of the work. You were still driving the car, but the system assisted you. That level 2 jumped that up. Now there was 2 systems on that vehicle that would help you. So now you've got maybe emergency braking and active cruise or something in lane departure. And that's where a bulk of the vehicles sit, is in that level 2, okay? Level 3 is what they call conditional automation. Now, conditional automation is the vehicle can drive certain sections almost by itself. Yes, you still have to have contact with the wheel, but the vehicle can drive certain sections by itself with little interaction by you. Level 4, basically it can complete all aspects of a drive under certain conditions. So that's you from home to work, it could do the whole thing. You're still there, but it could technically do the whole thing without you. Whereas level 3 could only maybe do the freeway section of your drive to work. Level 5, it does everything. Put in the direction, hit go, go to sleep. It probably doesn't even have a steering wheel or a gas pedal or a brake pedal, though they did add a big red oh shit button on a lot of these cars for when people panic. But level 5, it does everything. You don't need to do anything. You sit in the back seat and watch a movie. Okay. So what do we have on the road today? Arguably, Tesla is a high level 2. And Tesla is one of the most advanced systems out there. It is a high level 2, bordering on to a 3. The reason is Tesla has put in, for safety purposes and probably compliance and litigation purposes, you have to hold the steering wheel. You have to maintain a contact with the steering wheel. So that's that break point. The minute you got to have contact with that steering wheel, you are now a driver. Okay. So that Tesla is still that high 2, low 3-ish type of thing. Technically, Cadillac Super Cruise is a level 3 because you don't have to have your hands on the wheel with the Cadillac Super Cruise. And Nissan, that just announced last week their new Aria crossover EV, all-wheel drive, based off the evolved Leaf, they talked about their e-pedal 2 system. and their new, e-pedal system or semi-autonomous system is supposed to be a hands-off system. All right. We don't have really any cars on the road. There's no production cars that are 4s and 5s. The only 5 that I really know about is that little Waymo bubble car, not the big Chrysler Pacificas, the little round bubble car with the giant Easter egg on the roof. That's the only level 5 that you really see out there. I know Chevy has been doing some stuff with Cruise on the Bolt to where they have a flat dash, no steering Bolt. But I don't think it's been on the road a lot. But that little Waymo car, it's been out there. So that kind of gives us a little foundation of the different levels. So if we're living on 2s and almost 3s, there's a big jump to a 5. Hardware-wise, it's not that different. That's the key to this. Foundation of all this is ADAS. Everything we're talking beyond the ADAS is a better computer and the AI. The hardware's there, okay? Now, I love this picture because it always gets conversation. Is this a good thing or a bad thing? This guy's on his way back from a hard time in Vegas, and I guess that because of the mountains and the desert, so I'm thinking that, 15 or whatever, coming back from Vegas. And he's snoozing. So is this a bad thing? Yeah, the guy's asleep, but here it's also a good thing because the car is doing exactly what it's supposed to be doing. If this was you or me in our car, we're dead in the ditch by now. This car's driving down the road just as happy as could be. They have documented in many cases drunk drivers and people that have fallen asleep at the wheel where it's going down the freeway just fine and dandy, and the CHP have actually figured out a way to deal with them. It happened in Oakland not that long ago, and they get 3 CHP cars, 4 of them initially, and they basically box the vehicle, and what is the vehicle supposed to do? Well, it sees that distance and it starts to slow down, and they just slow the cars down and they move it to the shoulder, and the car comes to a complete stop, and they go over and then they tap on the glass to wake the guy up. Why don't they just light him up on the freeway? Because he's probably going to startle and crash. But they have found that they box him and they drive him to the shoulder, and the car does what it's supposed to do, and they get the guy, and everything's good. I brought this up at Mobilize last year, and I had a guy come up to me at breakfast the next morning. He said, "Did you hear the news last night?" I said, "What?" He says, "There was a guy last night in a Tesla, passed out, just like you had talked about, and the CHP pulled him over." Exactly the scenario I had said from up here. It had happened in LA the night before when I had talked about it. So it's a problem, yes, but the system allows us for it to not be a problem. That's what AI can do for us. That's what that autonomous vehicle can do for us. This is one guy dead or multiple people dead. When it does what it's supposed to do, it's nobody dead. So if ADAS is the foundation for autonomous vehicles, the piece that pulls it all together, the piece that works is the AI. So we got to learn something about AI.
I am a visionary, exploring a universe of data to sharpen our view of the most distant galaxies, and studying black holes to help prove Einstein's theory of gravitational waves. I am a healer, giving doctors the power to turn mountains of data into life-saving breakthroughs, identifying diseases like leukemia from a simple drop of blood, even in our own homes, and finding new ways to bring cures to market faster. I am a protector, keeping our oceans safe from invasive species, and helping our crops flourish while minimizing pesticides. I am a helper, assisting customers in stores and the disabled in their homes. I am a navigator, mapping our world 1 millimeter at a time, and making even the largest self-driving vehicles safer for the long haul. I am a creator, learning to paint from the masters and applying their styles to create original works of art. I am a teacher, analyzing 500,000 player moves every game to identify strengths and weaknesses. And a learner, discovering new strategies from complex games. I am even the composer of the music you're hearing. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
Okay, so you're sitting there going, well, I don't have an autonomous car and I don't have a robot in the hospital servicing me. You use AI every day. It's already involved in you every day. That phone call you get or the phone call you make to customer service and it talks back to you and it responds to you. Or every time you say, hey, Alexa, or hey, Siri, or hey, Google, or you go onto Netflix and it recommends, and my stupid Google just popped up, what do you want? Let me turn that back off. You go to Netflix and it recommends a movie. You go to Amazon and it recommends a product. That is all based on AI algorithms. What have you looked at? The Google ads you get when you surf the internet are AI based. It's looking at everything you're doing and saying, here, this fits with the things you're looking at, the things you're thinking about. So we already deal with AI at a very high level, okay? Now, how does it learn? Now, AI is based on something called machine learning and deep learning, okay? So machine learning is very much a pattern learning process. So let's take the example. We want the machine to learn to recognize a car. So we show it a picture of a car, and we show it a picture of a car, and we show it a picture of a car, and we show it a picture of a car. And eventually it learns, and each one of those pictures could be slightly different, but it's still a common profile. And now the machine learns, okay, that's the profile of a car. And it can now recognize, even if it doesn't have any color to it, if it's black and white, it sees the profile and says, that's a car. Then we continue to evolve it. And we start showing it parts. Here's a fender, here's a hood. And we go through that same repetition. And essentially, it's learning through recognition. It recognizes that physical shape, that physical outline, or whatever it may be. Every single one of us at some point in time has helped machine learning. You remember those goofy things when you would go to a website and it would say, pick out all the pictures of the stop sign in the pictures. I can't remember what those are called, GUI or something like that. And you had to identify every picture on the box that had a stop sign in it. Those were pictures that the AI, as they were trying to teach it, had trouble recognizing the car or the stop sign in that picture. And now you said, this is a stop sign. And now it learned, oh, okay. And now you've helped it learn what a stop sign looked like, or the bridge, or the bicycle, or anything else that it identified in that screwy picture that we all clicked on at some point in time. So that's machine learning. It's much more of a repetitive learning. Okay, it's I want to say monkey see, monkey do. All right, is a really simplified description of it. That is not what's being set up for a car. All right, that is not what's being set up for a car. For a car, it needs to be a more thought out process. So think about when you're driving and you see a kid crossing the street a quarter mile away. You're already recognizing that. You might be starting to let off the gas a little bit, and you're mentally preparing that I may have to step on the brakes. Machine learning would struggle with that forethought. Deep learning or neural networks, they don't. So a neural network is basically what deep learning is trying to create. Deep learning is taking that machine learning and evolving it and building these layers into place. So that takes that fender, and it can take that fender and now learn in 50 different shapes of what a fender is. And once it understands what the general shape of a fender is, then it could look at multiple shapes on any car or anything that looks like a car and say, I bet you that's a fender. It can start making, you know, for lack of a better term, make an assumption. Okay. That is what we're seeing in the AI for a car. It's an artificial neural network. It's a brain. It has learned how to learn. It has learned how to make intelligent decisions based on the information coming into it. Remember, we're trying to replace you. We figured out how to replace your eyes. We figured out how to replace some of your other senses, you know, with the radar and things like that. So now we're finding out how to replace your brain and your thought processes. And oh, by the way, this works a lot faster than you do. So now with all of that, you have that one scenario, and it's the scenario that, you know, everybody goes through, you know, life and death. Okay. So how do they look at AI and manage AI? And it's something called a trolley car scenario. Someone will die. It's a case of who and how many.
A runaway train is heading towards 5 workers on a railway line. There's no way of warning them, but you're standing near a lever that operates some points. Switch the points, and the train goes down a spur. Trouble is, there's another worker on that bit of track too, but it's 1 fatality instead of 5. Should you do that? Many people think the right thing to do would be to switch the points, to sacrifice 1 to save 5, since that produces the best outcome possible. Now imagine the train heading for the workers again. This time it can only be stopped by pushing a very large man off a bridge. His great bulk would stop the train, but he'd die. Should you do that? Most people say no. But why not? Both thought experiments are cases of sacrificing 1 to save 5. What the trolley problem examines is whether moral decisions are simply about outcomes or about the manner in which you achieve them. Some utilitarians argue that the 2 cases are not importantly different from each other. Both have similar consequences, and consequences are all that really matter. In each case, 1 person dies and 5 are saved, the best option in each harrowing situation. But lots of people say they would switch the points, but they wouldn't push the man off the bridge. Are they simply inconsistent, or are they onto something?
So the trolley car scenario isn't going to decide, are we going to have AI or not? And this is something that they actually put through people. It's used as a method of testing for ethical monitoring. So as AI gets smarter, it wants to think how it's thinking. So there's how a human would react to this, and they gave that scenario very well in that video. You'll flip the switch, but you won't push the guy. Your moral is to save the many over the few. But there's a big difference between pushing the guy off the bridge and flipping the switch, you know, direct or indirect. So it's one of the many scenarios, and there's a lot of these different kinds of trolley car scenarios that they'll run through. And it's just to kind of see how the neural network is thinking. Is it making rational decisions? And that's a lot of what the trolley car gives. The trolley car scenario is very much about making a rational decision. So that's one of the many tests that they put AI through. Okay. So autonomous vehicles. It's a system that's going to utilize cameras, sensors, and navigation systems to operate the vehicle with minimal or no driver participation. What's it going to do? It's going to improve passenger safety. It's going to lower our accidents. It's going to speed up our traffic, all that kind of stuff. It's an active system. The idea is with the autonomous vehicle is you're going to put in a destination and it's going to take you there. And you're not going to have to do anything in between when you're talking that full autonomous vehicle. It's really meant to replace or enhance all the driver's sensory awareness. So all these cameras, all these sensors, whether it's an ADAS car or all the way up to an autonomous car, we're just trying to enhance or replace the vehicle's or the driver's sensories and capacities, okay? And we're using a lot of systems to do it. So foundation in ADAS, cameras to see, sensors to see, that spatial awareness. We're going to use that AI to make decisions based on that data to control the steering, control the throttle, control the brakes, etc. And we're going to use those existing systems. So when you look at that graphic, that ADAS car, hey, we've got ABS brakes, we've got adaptive cruise control, collision warning, anti-sleep, the driver drowsiness stuff, and semi-automatic parking. On a connected autonomous vehicle, and notice I say connected, a big piece of a successful autonomous car is going to be a connected vehicle. It needs more communication information. So now it's auto steering, auto braking, auto vehicle spacing, so distancing, auto collision avoidance, fully automatic parking. It's an evolution of ADAS. It doesn't need to replace it. It just evolves it. It takes you out of the picture and it does it for you. Now, is the driver going to be notified by things? Sure, they're probably still going to get some lights or something. You see a lot of these concept cars that when they're in driver mode, the steering wheel's out and you can drive the steering wheel. When it goes into autonomous mode, the steering wheel disappears into the dashboard to where you physically don't have control of the steering wheel. Weather conditions are one of the big things. People say, well, why we're so far away from. Weather conditions are a big part of it because right now we know that our radar sensors and our cameras are impacted seriously by weather conditions. So how can I have a car with no steering wheel that can't be driven in heavy rain, sleet, snow, fog, smog, sandstorms, and things like that? They've got to have that next level of technology. And they're not exactly telling us what all that's going to be, but LiDAR is probably going to be some part of it because it has some capacities to see through some of those things, but it's still affected by others. Night vision is going to have probably a bigger part of that as well. Satellites are going to have a big part of that because they're looking above it in many cases. But our connected vehicles are going to start having more a piece of that. If I can talk to the other cars and I can talk to the infrastructure, now I have a lot more awareness too. So a lot of different things going on. And one thing we want to keep in mind, the human brain processes at about 60 hertz, or what they say 60 bits per second. The Tesla processor for its pilot system, one of the more recent ones, it's had a few different evolutions, is running at 2 gigahertz, roughly 36 trillion operations per second. So needless to say, it thinks a lot faster than you. And its electronics can take that mental thought and put it to a hand or a foot, in our case, a lot faster than we can. So it could see it, it could recognize it and react to it while you're still thinking about it, even though you might not be consciously thinking about it. Basically, they're talking about a data rate flowing with these autonomous vehicles. So they're in the hundreds of thousands of terabytes of data rate on these autonomous vehicles from all the sensor data, especially the camera data. Tesla is going to be very heavy on data because it's using cameras. The cameras have much more data flow than a radar sensor. LiDAR would have an expansive amount of data flow compared to a radar, but not as much as a camera. So there's a lot going on there, and it's doing it a lot faster than we are. So those components, it's everything we've been talking about. So for the 6 weeks and the first half of today, all the stuff we've been talking about are all those foundation pieces. This is what the autonomous vehicle is built on. Add a higher processing computer with more storage and the AI, and you now have an autonomous car. It really comes down to that simple of a difference. And we're just going to take that information in. It's going to go through that evaluation unit or that regulating control unit, throw those two things together, call them AI, and then it controls everything out of it. It's going to use information differently. I don't know if you noticed on the NVIDIA video, they talked about millimeter mapping. Millimeter mapping. GPS is like 3 feet. They're talking mapping to the millimeter, because one of the most critical things for an autonomous vehicle is spatial awareness. It needs to know exactly where it is all the time. Whereas with a GPS, I could be on the right road, but in the wrong lane, in the wrong direction, and it would still say it was okay. With an autonomous vehicle, I couldn't do that. So the millimeter mapping is a more precise location of that vehicle all the time. So that's a big thing. Well, GPS doesn't have that level, satellites do. So again, another thing that starts to support that evolution away from a traditional GPS to a satellite-based location system. Other things, lifting, lowering, all that kind of stuff, same problem as always. So all those same negatives from modifications and stuff, they still impact these systems as well, okay? Diagnosis. You're going to diagnose an autonomous car just like all the rest of them. You're looking for damage, you're checking powers and grounds, you're checking software versions, etc. You're being aware of weather conditions, because again, the sensors are going to be impacted by those conditions, past collision, all that kind of stuff. And the majority of the vehicles that have been in accidents, of the Google cars and the Waymo cars and everybody else, the majority of them have been somebody else hitting them. There's only been a couple of cases where they have hit something. And guess what? That's that learning curve. Now, people are going to say, well, one person dying from an autonomous vehicle is too many. How many people die from a human driver? I mean, I remember this exact same argument in the 80s when airbags came out. Oh, airbags, you get hit in the face with an airbag, you're going to die. They're going to kill children, da, 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 da. How many people were saved by airbags compared to how many people were critically injured or killed by an airbag? We've got that same kind of environment with an autonomous vehicle. How many people are going to be saved compared to how many people will be lost? So now we know something about diagnostics. Let's apply it. This is in Taiwan, I think. So notice there's the driver waving right there. And also see the smoke. That's where the brakes came on. Same scenario. Watch when he sees that, when the car sees where that person is, it hits the brakes, which is 50, 75 yards before it hits the truck. This scenario a little bit from what we know. We know that cameras don't do well with white. What was the color of the roof of that truck? White. Was that truck at 90 degrees to the vehicle or at an angle to the vehicle? Truck was at an angle to the vehicle. And I've watched it a bunch of times and looked at the shadows, and I don't think the car was looking at the sun, but the sun was pretty dominant from one side. So you start to think about, okay, and James says, not a good comparison. Airbag and DV dynamics are vastly different. This wasn't about an airbag. Oh, you're talking about my other thing. Never mind. So I look at it and go, okay, is the guy asleep at the wheel? Because technically he's still supposed to be driving the car. First and foremost, driver's still supposed to be driving that car, even when they're on autopilot. But can I understand why the car might not have reacted? Yeah, I'm looking at a white surface. Remember, Tesla is a camera-based autopilot. Yes, it has radar, but its number one priority input is cameras. So those cameras were looking at a bright white surface. That's not good for it. The radar was interacting with something at an angle. So radar, when it shoots out, if things deflect at enough of an angle, they don't return, they go away. If radar doesn't see enough return, it doesn't recognize that something's there. So in my mind, I can say I can see where the cameras let it down. I can see where the radar let it down. It did, you saw the brakes come on when it saw the person. It just, by then, physics, it wasn't going to stop in time. So that's the case where these are not perfect. Would a human have stopped? You'd like to think so. Now, if they would have added another sensor, it probably wouldn't have had an issue. If they would have had LiDAR on that car to where now it's printed across that truck more aggressively, it's going to get more return because it's hit a larger pattern of the truck versus the focus of the radar itself. And that would have probably compensated for the camera possibly losing sight at that time. Is that what happened? I don't know. But knowing what I know about cameras, understanding what I understand about radar, I can sit there and say, okay, these could be possible reasons for something like that happening. Because ultimately the car did react. So it's not that the systems were not functioning. Their reaction wasn't as timely as it should have been. Luckily, nobody was hurt or anything like that. So it starts to bring in some new parameters, you know, of what all is it going to take for this to be everyday thing. And that's why you still see a lot of people say, no, autonomous cars are a long ways off. Autopilot's been on Tesla for less than 5 years. And that's the point they're at today. Now, all these autonomous cars are really in a very compacted timeline. So it is a big difference, the rate at which progress is being made. Are we a couple years away? Probably. But that accelerates every day. So we'll see what happens in the big picture. When it comes to calibration, I think I showed this one before. When you're dealing with LiDAR, or you're dealing, in this case, a lot more cameras and things like that, it's going to take a lot more targeting. There's going to be turntables involved and things like that for everything to learn everything it needs to learn. So the calibration, it's still going to have targets. It's probably still going to have some dynamic and things like that. It's just going to be an evolution of what we're doing for ADAS. The big thing is, with all of this stuff, as we talked about it, is really understanding the liability aspect is huge on our industry. If you're an alignment shop and you did an alignment on an ADAS car and you didn't state in your documents that you did the applicable ADAS calibration following manufacturer specifications, and that car goes out and gets in an accident, all of a sudden you're going to get dragged into that just for that fact. So anything that you're dealing with in a shop that impacts an ADAS related system, component replacement, alignments, things like that, you better be preaching to your customer, preaching to your technicians and things like that. You've got to do the calibrations. It's a liability thing. And you've got to follow the manufacturer steps. So even if you're using that Autel or the Bosch or whoever's tool, most of that stuff is built based on the manufacturer stuff. You better follow it to a T. This isn't something you flat rate. This isn't something you shortcut. Because if you do and something happens, they're dragging you in. They're going to drag you in for sure. So keeping that in mind, that it's that serious. Okay. So hopefully that gave you a good chunk of what to see with autonomous and how ADAS evolved becomes autonomous for us. So if you got questions, let's throw them in there. Let's see here. Back up here. Ruben, what model of Nissan is that considered 3? It was the Aria. It's a brand new. They just announced it a week ago. It's a crossover. You can get it in front wheel drive or all wheel drive. They're saying up to 300 miles range. And I want to say they called it ProPilot 2 or ProPilot 3, something like that. And that it was supposed to have a hands-free functionality. It still has a steering wheel, so it's really going to be like a level 3 car. It's not a 4 or anything like that. Ned, Hyundai's Asimo robot has some AI. Yeah, it's running on AI. Paul, adaptive memory in the software, programming and AI. When I think about adaptive stuff, I think about today's engine management even. It has enough I can't get the word out of my mouth at the moment. It has enough advancement in it that it becomes very rational in its thinking. I had problems setting faults in cars for about the last 5 years because I'd try to put a fault in and the system would say, this is bad. You know, it was too high, this, too high. It was too direct because it understood the system so well that it became hard to put faults in without having a defective part. So the old tricks that you would always do, you know, insulate, you know, take some of the ground away, not eliminate it, but reduce it, or reduce the power with resistors and things like that. The systems became so smart that it would just take them to the fault too quickly. I think with the software and AI, we're really going to see that constant learning. I mean, Tesla already basically, it phones home to mama every night and it says, here's where I've been. And, you know, it takes downloads and then lets you say, yeah, I want to load it or I don't want to load it. You're going to see that increase. I mean, every car out there is finding ways to do over-the-air updates. Historically with cars, when we've done a reprogram, and we'll talk about this in 2 weeks in programming, historically we'll go in there and erase the computer and rewrite everything, kind of as a safety issue. Tesla, on the other hand, they don't rewrite. They'll go in there and replace that section of code. It's a smaller packet. It's easier to transmit that way with a greater chance that it's going to be successful. If I tried to erase the engine control module in your car in your driveway and then reprogram it overnight on a 12-volt battery, it's not going to be very successful. But on a high voltage car, if it's plugged in, I have a better chance. But I have an even better chance if I just go in there and replace the lines of code that I need to, or better yet, I don't even have to replace that line of code. I put a code in there that says, here's a link to the code I want you to do when you get to this spot. And it's like a hyperlink. It just goes, instead of doing this one, do this one instead. Or I add a feature, or I take a feature away. So we're going to have stuff going on in those. What I've seen with the test cars for the autonomous, you know, it's a PC back there with a whole lot of memory and as hot rodded as it can be. And that's one of the things holding it back a little bit is the heat, the space, the size of the computation. It needs a lot of space. It needs a lot of cooling. It needs to run really fast to think. The software is probably closer than some of the hardware in some cases. Ruben had one. According to the video, over 1 million people die in auto accidents at 90% human error. Yeah, you know, that was an FIA video, so that's probably a worldwide number. That's scary. You know, it's scary, and I think it's getting worse as people are more and more distracted. James, not a good comparison. Airbag and DV dynamics are vastly different. The dynamics are different, but the customer perception was very similar. A lot of people are saying, I don't want autonomous cars because they're going to kill people because there's not a driver thinking. And what we saw with airbags when they came out, airbags are going to kill people because it's going to punch them in the face or it's going to break their neck. And they take that one aspect and they apply it as a blanket, where very quickly they learned that airbags saved a whole lot more people than they ever injured beyond a rug burn. And the autonomous are going to have those same growing pains. There are people going to die when a car is in autonomous mode. There's people already dying in driver mode. What's the difference between people that die by a driver and people that die through autonomous? That becomes the big discussion. Let's see here. Honda had one, and Honda called it fuzzy logic at one time in transmission shift algorithms. Yeah, it's just logics. It's just the way the system is thinking, and the more advanced systems are thinking better, and they're not just black and white. I see this, I do that. The newer systems are now able to rationalize. It used to be, let's say you had a 5-volt sensor and the computer was seeing 12 volts. It would just say voltage out of range or, you know, whatever, sensor fault. Now it can say voltage out of range too high. So that extra rationalization, it can just provide more information, or it can make a better decision. James, remember the discussion when OBD first arrived? Do you see any similarities, especially those related with software protection and sharing data with independent shops? Yeah, autonomous is going to be not that different than any of the new technologies. I mean, we go back, OBD was dealer only for a long time. Airbags, dealer only for a long time. ABS, dealer only for a long time. Hybrid, electric. We see this as the new technologies come out. They're really exclusive to the manufacturer because they're carrying the liability. So they're training their people to support their product because they're owning liability. They don't make that information public because if Billy Bob's Bait Tackle and Autonomous Vehicle Repair screw up, they're not going after Billy Bob. They're going after the manufacturer who's got the wallet. And so that comes into play with this. The bigger reality is, though, is we see hybrids and EVs and stability control and autonomous vehicles that get out of the warranty period, and now they're in the aftermarket. And somebody needs to service them. So that trickle-down effect comes into play eventually, but it took a very long time. That's why all of our hybrid and EV courses were based around Toyota Prius. Toyota had information out through the T10 schools, and it got out, and that's what we all built stuff around, was the Prius, because that was the information we had. And that's the challenge, like I said, right at the beginning of all this, is the industry's dying for training, and it's not there because in a lot of cases, the manufacturers aren't providing it outside their network. And in some aspects, like an EV bus, they don't even have it for their own system. They're selling the bus, but she'll probably figure out how it works, you know. So that's a different ball game. Robert, can't help but to think about the pay issue for technicians as they begin to learn and understand the systems that have to be serviced. When do you think the industry will begin to recognize pay is going to be a main issue for technicians? When we lose enough of them. When we lose enough of them, when it becomes so specialized and so complex that anybody can't just open a shop on their own and say, I work on cars. Because we all know, and I've got friends of mine that have no formal education and have run auto shops for 20, 30 years. You can't do that with these systems, not very effectively. So I think that, you know, as there's a contraction in the industry, and there is a contraction in the industry today, there is going to be a contraction in the industry going forward. It is going to be more complex. It's going to require a higher level of technician. Those are absolutes. We see that now from 20 years ago. So there's a precedent there. Maybe then it will become an industry where there's a whole different level of respect and association with it. I've said for many years, licensure. You want to make more money? Require technicians to be licensed. I don't remember what the current number is, but for a long time there, it was like 60 or 70% or more of the technicians failed their smog test on their first attempt. That was a licensure. If they had licensure for technicians in the industry today, you'd have less technicians and hopefully it would have a better quality, you know, if they had some aspects to it. That affects pay. So pay is always going to be never enough. John Taylor, as AI becomes more complex, we get farther removed from the algorithms, and the engineers can't even understand the logic and code that the AI develops to analyze issues. Yeah, that's one of the side effects of neural networks. It learns how to learn. You know, part of deep learning is for the system to learn how to learn. As it goes deeper into the neural networks, it's creating its own brain functions. You know, who is it? Musk. He's real afraid of the singularity when the computer becomes self-aware and all that kind of stuff. If it's intelligent enough and it's been taught the right way, it's going to learn, and it's going to learn real fast, and it's going to get more complex. And I would like to think that people are smart enough to figure out what it's doing. It just may figure it out before we do. We'll see. Probably won't be around then. Ed Snyder, airbags and passive safety important as time went on. They did have stumbling blocks. Exactly. And, we've seen the stumbling blocks with, the pro pilots and the super cruises and stuff like that. And we're going to see that. Right now we're still dealing with kind of older technology with the cameras and the radar and things like that. It's that Gen 2 stuff. When those things come down the road, the things they're working on today that we'll see in a couple of years, those are the things that are going to make a big difference in these systems for capacity and reliabilities. Mark Burbeck, will my car of the future be able to get along with me? Only if you bring it wine and cheese and chocolates and things like that. If you treat it nice, it'll tolerate you. Otherwise it might just crash on it just to get rid of you.
Well, I figure as soon as it starts learning, right, it'll learn to hate me.
Yeah. And the thing is, we saw on the Subaru last week on the driver drowsiness stuff, the Subaru recognized the driver. Okay,
Hey.
so cars before that, they recognized you by what remote you used or what key you used, and it referred to driver 1, 2, and 3. That system, it learned your face and said, "Hi, Mark, how are you today?"
Are you going to go over in the next couple lectures? Remember when we were down in San Jose, and we were at that AI facility, and one of them had like the inside cameras, and I think they said, well, we have 4 cameras now, and we're working on putting 20 cameras in.
We talked about that a little bit last week with the driver drowsiness stuff.
Yeah.
That it was using cameras to recognize your blink rate and yawning and things like that. So that's really a low level of that kind of system. The stuff that we saw in San Jose was much more advanced and many more cameras, because it was, almost like the live lie detector test kind of thing. It was looking at a whole lot more than, are you blinking? What's your blink rate? Are you yawning? Is your head falling over?
Are you being aggressive?
Yeah.
Should it adapt driving for your being aggressive? Or are you falling asleep? Does it need to pick a different music?
Exactly. And I know that I remember reading something that one of the parameters that, down the road they anticipate is the tie-in between that driver drowsiness and the climate system and the music. That, and I think the Mercedes video even mentioned it, that as you became a little less responsive, that it would turn the AC on and it would change the music to one with a more active tone, take you to metal music or whatever from your elevator music. So
that's where Master and Puppet
yeah. So I mean, this stuff
comes in.
There's a lot of the hardware. It's physically there. It's just a matter of, is there a need or a justification to write the software to make it do it? That becomes the big piece with this stuff. Let's see here. Ed, someday artificial intelligent devices may keep people as pets. Hey, I'll tell you what, how many people are slave to this? Ask your teens and your tweens and what have you. They lose this, they might as well cut off 2 arms and a leg, So we're already there. Long live the small block. That's boring. Tesla eats them alive, going backwards, uphill, towing a trailer. Paul, sounds like with auto updating, no maintenance, we'll need very little repairs. Yeah, EVs are part of that big change. I mean, it's already pretty well known. The car dealers at the sales level don't promote EVs like they promote internal combustion engines. Why? Because there's not as much service maintenance on an EV as there is on internal combustion. You lose all those oil changes and things like that. Do brakes still wear? Yeah, just not as fast. Do tires still wear? Yes. Do wiper blades wear? Yes. Do I have body electronics issues, window regulators and things like that? Yes. I just don't see the powertrain failures as much. We've got motors that they're testing at 1 million miles. They expect the 1 million mile battery to be announced, next month or something like that. So you're probably not going to be doing the heavy duty powertrain stuff, but you're probably going to be doing the body electronic stuff and the ADAS stuff and the AI stuff. So the technicians, it's going to evolve. That guy, we all know that there's some people that their future, their best thing is going to be the heavy duty guy in the shop. I didn't want to do heavy duty when I worked in industry. Man, I gave away gravy customer pay heavy duty jobs because I just didn't want to deal with getting that dirty. And I would deal with the diagnostics and the squeaks and the rattles and the water noises and the wind noise and all that garbage. That was what I liked. I didn't like the other stuff. Well, the difference is I could do the other stuff if I wanted to. The heavy duty guy might not have been able to do what I can do. And that's probably what we're going to see as the technology continues forward. It'll be the person that can handle the technology could probably also handle the heavy duty, whereas the heavy duty guy, if they can't handle the technology, it's going to be a tough spot for them. You know, and if the heavy duty's not failing, if that motor doesn't fail, I don't need a guy to take a motor out. If the battery doesn't fail, I don't need a guy to take the battery out. So it's an evolution. It's going to be different. The maintenance, cool. That's all I got. If you got more stuff, throw it in there. So next week, connected vehicles. And we will talk a little bit about how you can start bringing this into your classes, whether it's in pieces or capstones or whatever, certificates, whatever, because I think it's a lot easier than you think to bring in some conversations and some awareness. So we got connected vehicles next week, which is important. It really starts to bring a lot of things together for those next steps towards autonomous. And then vehicle programming, not new, but critical. Let's see here. Ed, if the battery on a Tesla could be changed in 4 minutes, no job there. Yeah, it's a little more than 4, though I think they had those quick stations that they were trying to get there, and then they closed them as fast as they opened them. But if it doesn't need to be changed because it's got a 1,000,000-mile range on it, you know, show me a gas car that you drove 1,000,000 miles on in most cases. Not there, few diesels. So yeah, the heavy duty side is going to be different. It really is. Service in general is going to be different. Cold fusion power generation. Well, that was an option in the DeLoreans with that triangular funny thing, you know, but they skipped 2020, so we won't have that car. I don't know anything about fusion. You know, the sun's up there. That's fusion. Too big to put in a car. Capacitor. That was the word. Thanks, Ed. I knew you were a junk.
Capacitor.
That's all I got, guys. If you got stuff, throw them in there. Otherwise, enjoy your weekend, and we'll see you next week. Unless Pam's got something.
Stay safe.
Take care, everybody. Thanks, Kurt. Thanks, Pam.
No problem. See you, everybody. You can go ahead and stop your recording.